All right. So the key idea for the day is, can we write the equation of an ellipse when we're given information about it? So it's a bit backwards of what we've been doing lately. So in order to write the equation of an ellipse, you need to know the center. Um, and that's HK. And then you also need to know A, and you need to know B. And if you know those things, then you can write the equation of an ellipse. So let's start with this one on the screen here. So it says to write the equation if the center is at 0, 7. So this is kind of nice. Delta math will just kind of let you tinker around and plot points. So I'm going to start by putting a point at 0, 7, and that is the center. And then the horizontal major axis with a length of 18. So since the whole axis is 18, you just need to go out 9. And that's a distance of 9. And that's a distance of 9. And then they also tell us that the minor axis has a length of 8. And we split that in half, 4 for the up and 4 for the down. So 1, 2, 3, 4. 1, 2, 3, 4. So the graphing part of this isn't like part of the problem. You don't have to do it. It's just for visualization purposes. But um, these types of problems where they give you basically, you may not see it yet, but they give you everything you need. These ones are pretty straightforward. So we know the format of well, let's write this down first. A is this distance right here. It's the length from the center to one of the vertices, the main vertices. And that, um, since it's a distance of 18, that's a distance of 9. So A is 9. And then since the vertical axis is 8, then this little one, I'll draw it in purple. So like this little one right here is the minor, well, the semi-minor axis, half of it, that's going to be our B value. So anyways, A is 9 and B is half of 8, which is 4. And that's pretty much it as far as, I mean, that's all you need to write the equation. So we already know the format of the equation is going to be something over something plus something over something equals 1. And since the center is at 0, 7, then we know it's going to be like x minus 0 squared. And then the y part of it is going to be y minus 7 squared. And then since it's a long ellipse, it's a horizontal ellipse, one of the long sideways ones, then we know that the format, the a value goes underneath the x, is what I meant to say. So a squared is 81, so that goes under here. And then b squared is 16, and that goes under here. And that's it. And then you just have to type that in at the bottom of the screen. And to do that, I think what I'd recommend is just make your fraction first, put a plus sign, make another fraction, and put equals 1. So then like for the first one, you can just do x squared over 81. And then the second one, you need parentheses, y minus 7 squared over 16 equals 1. And that is that. So let me search through here and find one that's a little bit more challenging here. So this will be a good example here. So just one more problem, and then the rest, if you understand this, then you can pretty much figure out the rest. So the key here is, again, let's visualize. And so we have our foci at 510 and 54. So there's a focus at 510 and a focus at 54. And because those are the foci, they have to lie along the major axis. So the major axis is where I'm moving my mouse here. You can see kind of me moving up and down. And the major axis has a length of 10. So we would also agree that the vertex, or the center, excuse me, has to be right halfway between the foci, which would be right there. And since the major axis length is 10, then you know that you split that in half and do 5 up and 5 down. So there's 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So those 5 points, that can be a little bit confusing, but here I'll just kind of write on this for you. So this is the center. Obviously, I probably don't need to label that. This one and this one are the foci. And then these ones down here and up here, those are the vertices. So what we can gain from this is we know some values. It's all about A, B, and C. So what we know is that A is 1, 2, 3, 4, 5. And what we also know is that C is equal to 3. But if you remember from a few minutes ago, I said that in order to write the equation, you need to know A and B. And we don't know B. So for that, what we're going to do is head over here. And you'll remember you have this equation on your cheat sheet. C squared plus B squared equals A squared. So we're going to take that equation and modify it to allow us to solve for any one letter that we want. So like if I just kind of leave it alone and switch the sides, I get A squared equals B squared plus C squared. And then if I take the square root of both sides, then I can say now that A can be found by doing the square root of B squared plus C squared. But then if I wanted to say get B by itself, then I could manipulate that equation up there, the one in the oval there. I could say, oh, so B squared, if I get it by itself, is A squared minus C squared. So that's just me moving the C squared to the other side. That's some really basic algebra. So then B is equal to the square root of A squared minus C squared. And then finally, I don't think there's a real practical purpose in this particular assignment for it, but if you wanted to solve for C, like if you knew A and B, but you wanted to find the focal distance, then you could solve for C, again, by just kicking one of the terms out. So like we would have the C squared alone, and then we would have A squared minus B squared. And again, we just take the square root. So if you're watching this video, this would be a good place to like probably pause it and make sure that you write down the 3 things in the purple box, because they're what are going to enable us to solve for any of the 3 variables, depending on which 2 we know. So back to our problem, we know that we know A and we know C, but we don't know B. So B is equal to the square root of A squared minus C squared. So B is equal to the square root of A squared minus C squared. Well, in our case, that means that B is going to equal the square root of 25 minus 3 squared is 9, which is the square root of 16, which means that B equals 4. So if I add that to my information list over here, the 2 now that I need are A and B. You don't need C to write the equation of an ellipse. Like we needed it to find B, but that was the extent of its usefulness for us. So knowing that that's the major axis that goes up and down, then we know it's a vertical ellipse, which means that the stronger number is going to go underneath the y. So first, let's just build the structure of it. So we have something over something plus something over something equals 1. It always equals 1. And then since the center, and I haven't actually written this down yet, but we know that the center is right there. And we know that the center then is at the point 5, 7. So that means when I write the numerators of my equation, I'm going to have x minus 5 squared and y minus 7 squared. And then for the bottoms, because it's a vertical ellipse like that, and again, we know that because this is the major axis right here. So because it's a vertical ellipse, then we put the a squared, the 25, underneath the y. So you'd want to put 25 here. And then the b squared, the 16, goes under here like this. And that is how you write the equation of an ellipse. Use the graphing utility to your advantage. Again, the graph is not part of the problem. It's not judged. It's just almost like a little sandbox where you can plot points. And you could, of course, do these on your own graph paper if you wanted to. But you should have enough information. Well, you will have enough information in every problem to find some combination of A, B, and C. Like you might find A and B, you might find A and C and have to find B, or you might know B and C and have to find A. But that's basically the gist of it. And then there's a bunch of problems that are right here in Delta Math that I'd like you to work on. So that is that. And I'll see you.